Would you like to know how you can reduce your commissioning time of your machines by up to 50% and complete projects or newly developed machines on time and on budget? It's simple with Simulation for Automation. A seamless integration of automation and simulation and the continuous integration of new functions give you future-proof solutions. As a machine builder, you can use simulation to validate and optimize your production machines. That's the key to building better machines faster. You have an order to deliver an automated machine, and the PLC program needs to be validated before actual commissioning. Traditionally, this process uses test setups or prototypes, which is very time-consuming and requires corresponding hardware components. Our suggestion: test the PLC program with a simulated SIMATIC controller and check the behavior of the electrical components. If a machine requires special safety functions, the smooth interaction of standard and fail-safe automation also needs to be ensured. In this case as well, you can validate the safety functions in automation and simulate them with SIMAT. So far, you've only integrated the mechanics and the automation on the real machine? Then you know how time-consuming and cost-intensive this process can be. For example, due to wear and tear on the prototypes. The good news is that full simulation of the mechanical design and automation code can be performed together. Simulate and visualize the behavior of the machine in a 3D environment with NXMCD and simulate additional component behavior with SIMAT. When designing a new machine with electric drives, are you lacking empirical values or load profiles? This can easily lead to oversizing the drives. You can select and parameterize the converters and motors for your application based on load profiles generated by the simulation. This reduces time to market and costs by testing the machine design under real conditions. For machines with multi-physical systems, you need to find the optimal parameter setting of the automation and/or dimensioning of the components. Our suggestion: simulate the relevant multi-physical subsystems and the associated automation, and bring both together in a virtual environment. This allows your machine behavior to be tested by combining PLC code with an integrated simulation environment that takes into account all relevant physical areas. Last but not least, operators can be trained on a virtual model before the real machine even exists. This eliminates the need for expensive and time-intensive training on the real machine. Summary: the seamless integration of automation and simulation offers companies the opportunity to put validated and optimized production machines into operation. Join us on the path to efficient and digitalized production.